In this video, we'll learn about dimensional analysis and similitude. What is dimensional analysis? Dimensional analysis is a mathematical technique which makes use of the study of dimensions as an aid to the solution of engineering problems. Or in other words, we can say dimensional analysis is a mathematical technique used in research work for designing and conducting model tests. Now we'll learn about the uses of dimensional analysis. Dimensional analysis is useful in both analytical and experimental investigation. It is used for testing of dimensional homogeneity of any equation of fluid motion. It is used for deriving equations expressed in terms of non-dimensional parameters to show the relative significance of each parameter. It is also used for planning model tests and presenting experimental results in a systematic manner, thus making it possible to analyze the complex fluid flow phenomenon. Here we can see an example of the use of dimensional analysis. Suppose the drag force F per unit length on a long smooth cylinder is a function of airspeed U, density ρ, diameter d and viscosity mu. However, instead of having to draw hundreds of graphs portraying its variation with all combinations of these parameters, dimensional analysis tells us that the problem can be reduced to a single dimensionless relationship. What is the relationship? That is, CD is a function of RE. Now what is CD and what is RE here? CD is the drag coefficient and RE is Reynolds number. In this instance, dimensional analysis has reduced the number of relevant variables from 5 to 2 and the experimental data to a single graph of CD against Reynolds number. So we'll understand about the use of dimensional analysis in details. So let's complete the video. At first we have to know what is dimension. Dimension is the type of physical quantity. We know there are two physical quantities. One is fundamental quantities and another is secondary quantities. Fundamental quantities includes length, mass, time and sometimes temperature. So these four are fundamental quantities. The dimension of length is L, the dimension of mass is M, the dimension of time is T and the dimension of temperature is theta. So we get L, M, T and theta as our fundamental quantities or primary dimensions. Now here we get the secondary quantities. Secondary quantities are those which possess more than one fundamental dimensions like velocity, acceleration and density. The dimension of velocity is L into t to the power minus 1. So here we get two fundamental dimensions, that is L and t. In case of acceleration, the dimension is L t to the power minus 2. In case of density, that is M L to the power minus 3. So these are the secondary quantities or derived quantities from the fundamental quantities. Now, what is dimensional homogeneity? The dimensions of each term in an equation on both sides are the same. Then we can say that it is the case of a dimensional homogeneity. An equation is said to be dimensionally homogeneous if the dimension of the terms on its left hand side are same as dimensions of the terms on its right hand side. Let's take this example. Here we can see on the left hand side that is S and on the right hand side is ut plus half at square. So dimension on the left hand side for S is L and for the right hand side we get the dimension of ut is L t to the power minus 1 into t. So here we get also L, and the dimension of half at square is L t to the power minus 2 into t to the power 2, again L. So here we can see that the dimension on both the side, that is left hand side and the right hand side, are same, that is L. So therefore by definition we get the equation is a dimensionally homogeneous equation. Now we learn about the model analysis. What is model analysis? Model analysis is the experimental technique of finding solution of a complex problem. What is model and what is prototype? The model is the small scale replica of the actual structure or machine, and prototype is the actual structure or machine. Here we can see this is a prototype car and this is a model car, which is a replica of this car. So we learn about the model analysis in details. What are the advantages of this model analysis? By using model analysis, the performance of the machine can be easily predicted in advance. So before going to in practical use, we can test its performance by using a model. Next is, with the help of dimensional analysis, a relationship between the variables influencing a flow problem in terms of dimensional parameter is obtained. This relationship helps in conducting tests on the models. So by using the dimensional analysis, we can perform the test on the model. And the merits of alternative designs can be predicted with the help of the model testing. The most economical and safe design may be finally adopted. So by using various models, we can find which is the best model and we can finally choose our desired prototype. Now, what is similitude? Similitude means type of similarity. So similarity between a model and its prototype. There are basically three types of similarity. One is geometric similarity, another is kinematic similarity, and last is dynamic similarity. We learn about all these similarities. So let's learn about geometric similarity. What is geometric similarity? Geometric similarity exists if the ratio of all corresponding linear dimension in the model and prototype are equal. Here you can see a prototype and here is the model. Here we can see the length of the prototype and width of the prototype, and here is the length of the model and width of the model. So if it exists that LP by LM equals to DP by DM equals to DP by DM equals to LR, so this is known as scale ratio, and AP by AM equals to LR square, which is known as area ratio, and VP by VM, that is LR cube, which is known as volumes ratio, and LM is the length of the model, BM is the width of the model, DM is the diameter of the model, AM is the area of the model, and VM is the volume of the model. And by putting P in the suffix, we get our corresponding value for the prototype. That is LP, BP, DP, AP and VP. These are the length, width, diameter, area and volume of the prototype. Now what is kinematic similarity? Kinematic similarity exists when a condition exists that there is the similarity of motion between the model and the prototype. If the ratio of the velocity and acceleration at the corresponding points in the model and the prototype are the same in magnitude and the directions are also parallel, then we can say there is a kinematic similarity between the prototype and the model. Here you can see a prototype and this is the model. So here the velocity of the prototype is Vp and the velocity for the model is Vm. If such condition exists that Vp1 by Vm1 equals to Vp2 by Vm2 equals to Vr. So, this is known as velocity ratio. So, here is a similarity between the model and the prototype, and also if the acceleration ratio is same, that is similar between the model and the prototype, such as AP1 by AM1 equals to AP2 by AM2 equals to AR. This is known as acceleration ratio. If such condition exists, so we can say the model and the prototype are in kinematic similarity. That is similarity in velocity and similarity in acceleration. Now, what is dynamic similarity? It means the similarity of forces between model and prototype. Here we can see the prototype and model, and here is the similarity of forces in case of prototype, and here in case of model. The forces are similar. So if the force ratio exists, that is Fp1 by Fm1 equals to Fp2 or Fm2 equals to Fp3 by Fm3 equals to Fr. Fp is force for prototype and Fm is force for model. If such condition exists, so we can say the model and the prototype are in dynamic similarity.